Now one more thing, why I have not counted etcd in a control plane component. See why we are not counting etcd in a control plane component, because in some of the cases, if this is your Kubernetes master and this is 1 2 3 4 component, API server, node controller, kube scheduler, and replication controller, we are having etcd here, but this is optional. If you don't want to put it under master server, you can deploy a separate server outside your Kubernetes cluster and you can deploy etcd here. Then you can ask your API server to read and write information from here. So whatever the status of cluster, whatever things you want to read and write there, you can put it over there. So that means every single thing, including cluster information, you can write here. And who will do the job? Kube API server. Yes, Boni. If Kubernetes master will go down, your application will be maintained. Cluster is a different thing. But we have such an architecture, so don't worry if the master is go down. I'll be answering to that question, because we can have multi-master in that case. Okay, fine. So etcd can be outside it, that's why we are not calling it we are calling it Kubernetes control plane component. Okay, now see, we have so many components running here. So you know what, for a Kubernetes administrator or engineer, it's really impossible to maintain and manage these many services one by one. So there is a service in Kubernetes master, we are calling it kubelet. What kubelet will do? Kubelet can maintain all those components alone. So that means it's a kind of daemon or service that is maintaining or troubleshooting and managing all these components for Kubernetes master. Even it is also responsible for connecting to another kubelet running anywhere else. Okay, so for that thing you have to wait for one or more session. You will get your answer automatically. So every components are individual, okay, and every component can connect to etcd, but how, that is the question, right? So etcd never going to connect anybody, all the components will come to etcd. By the way, this information will be maintained and managed by only API server. Right? Alright, so now kubelet is something that will managing this Kubernetes master entirely. Going back to this architecture again. Okay, now we have done with the Kubernetes master component. These are not all the components, actually there are so many, but at least these are the ones that you really need to understand. Okay, and these are the most important and most popular components of Kubernetes master. Going back to minion nodes, so we have minion 1, we have minion 2 and minion 3. everywhere we have installed Docker engine, and the Docker engine is running smoothly. Okay, let's say if you remember that fact, whenever you install Docker engine for the first time in any of the machine or node, what else things are coming by default? So a bridge called Docker 0, another bridge called Docker 0, and same Docker 0. So if you install Docker for the first time, generally a bridge called Docker 0 will be coming to each and individual node, and because the bridge name is same for every Docker, every new instance, IP will be same. Okay, now say if you launch container 1 here, it will be getting IP from here, container 2 here getting IP from here, container 3 here getting IP from here, because we have so many, we have 1 to 3 million node, and so many containers can launch there, here and here, because Docker 0 is the only interface that is connecting in every system. So you know what, these containers can have almost same IP as these container or as these containers, because you know what, every time you install Docker in a new machine, they will get a fixed series IP address of this, of this, of this. So let's say 50 container are here, and 50 container are here, and 50 are here. Each 50 container can show the conflict of IP irrespective to the worker node. So that means in the minion node 1, node 2 and node 3, if you go and check, there is a lot of possibility of same IP assignment by Docker bridge, because Docker bridge is offering this IP, right? So definitely Kubernetes is not going to use Docker 0 bridge to give IP address to container, because if they have same IP, how they can communicate, right? If you are understanding this problem, that Kubernetes cannot use Docker networking like Docker bridge or something, so we need to think a solution for the same. Okay, so if you are understanding that fact, Kubernetes cannot use Docker networking across the minion node, because the IP can be conflict, and if the IP is conflicting, how container 1 from worker node 1 will communicate to container 2 to worker node 2. So we don't need container based networking or Docker networking in Kubernetes cluster. If you understood the point, say yes in the chat window, and if you don't, I can repeat it again, hoping for your responses. Alright, so make sure you are understanding it very well. Right? Great. Anyway, fine. So if you're not going to use Docker networking, then what we'll do, will not use Docker networking, we will create a common bridge, one bridge, let's say called Ashutosh bridge. Okay, and the same bridge will be connecting to this Docker engine, and the same bridge will be connecting to this Docker engine sorry, and the same bridge is connecting to this Docker engine. Now rather than having individual Docker bridge in every single system, will have a common bridge across the worker node. So that means we'll create one virtual bridge that will be connected to each and every Docker engine. So even if you create container here, it will take IP from here. If you create container here, it will take IP from here. If you do create here, it will take IP from here. So this single bridge will be responsible for giving networking solution to all the containers across the minion or worker node. Even master node will also be connected to, so because Docker engine is running in the master node as well, so your master node will also use the same bridge to connect. Okay, now who will create that bridge or such a bridge that has connectivity with all the Docker engine in the Kubernetes cluster? So there are so many open source networking solutions like Flannel, like Calico, like Callium, right, like WaveNet, and so many. So any of the networking, or we have Cisco ACI. So we have so many networking projects. You can use any project to create this bridge. Any one, right? Not all. You can use any one. We are going to use Calico for the bridge as of now. There are so many reasons behind that. So Harshvardhan is yes, Harshvardhan. So the concept will be same for other container orchestration tools, but networking plugins will be different. Yes. So even this will be same, but networking plugin will be different. Right? So about this, right, if you understood it very well, then it's okay, we can talk about the same. Right? Say yes in the chat window. Right? Okay, so we are going to use Calico, right? Now one final component, because there are so many, make sure you are not getting confused in one way or another, right? So just keep that patience. All right, now the final thing, see, so what final thing is going to happen? This will be my Kubernetes master, here will be my minions, they all are connected to each other like this, and the most demanding component in Kubernetes is Kube API server, and a developer or user can connect to this, then it can pass to Kube scheduler. Kube scheduler will find the right node and deploy container here. These containers will get networking from a common bridge technology, and here we'll be using Calico. Okay, in some cases you can also schedule container here. I'm not saying you cannot, it's possible, but by default Kubernetes does not schedule any container in Kubernetes master node. See, So now let's say if the container 1 is here, container 2 is here, container 3 is here. Okay, now I want container 3 can communicate to container 1, container 1 can communicate to container 2, but container 2 cannot communicate to container 3. Okay, so who will maintain this communication of containers across the node? It doesn't matter either they are in the master or in the minion node, but I want the control in communication in the containers. So a component running everywhere in Kubernetes cluster, and that is kubeproxy. Kubeproxy will maintain the communication between container across the worker node, right? It will maintain the communication between container across the worker node, like worker node 1, 2 or 3, like this. Okay, so here it will be running, and because in the worker node also the component kubelet will be running, because kubelet is responsible for connecting to master node that I'm healthy or not. Okay, so kubelet is like a main component of this that can maintain the, yes, I need to report it back to master, and kubelet has also this functionality. So I hope kubelet, just ignore it for now, but you are understanding this kubeproxy. If kubeproxy is understood, finally you can say yes, and we are done with the component of Kubernetes as of now, as per the requirement, right? There's so many things, but okay, it's all right as of now. And now we are going to talk about installation of Kubernetes cluster. Okay, installation of Kubernetes cluster as of now. Okay, so what I'll do is, let's have a tea break, because it will take time of 10 minutes only. I need to do something, preparing some tea or something. 10 minutes. It's around 12:30. So 12:40 will be back. Exact 10 minutes.